Oh, okay. Hello again. The microphone is mute again. Okay. Start off from the previous time that we already implement the percent encode algorithm. Right now, we're going to go deep down into implement the detail of the signature itself. Going through step by step to getting the signature back. Yeah, thank you, Shell 62 for coming. A little bit laugh at the beginning, but anyway. Alright. So as you can see that now we're focusing on signature. In order to get this information is on this page. Create signature. So the example you see here is that is a HTTP request here. Is post method that request along with another parameters that going to send, and as well this status here is a parameter for the tweet data that we're going to send. So the step is this: to produce signature, start by determining the HTTP method and URL of the request. These two are known when creating the request, so they are easy to obtain. Yep. The request method will mostly always be get and post for Twitter AI request. The base URL is the URL to which request is direct minus any query string or hash parameter. It is important to use the correct protocol here, so make sure that the protocol is correct. Okay. So we are going to gather all the parameter include that we are going to send into the request. Right. Yeah, we're gonna make it easy because we focus only at the moment. We're in minimalist Twitter CLI, so just focus on the tweet functionality. Yeah. Let's see what the function we're gonna include. And I think that we might not going to automatically sort here. We're gonna manually sort for Twitter update function. Yeah. Okay. So this is it. TT2 generate signature. Okay, everything automatically to be including some control. Code does too. Here the parameter for authorizing first. Alright. I'm gonna change the function signature a little bit to be more suitable and focus on the update function. So pt util generate signature for update API. Right. Yeah, let's go for the simple case for now. Very flat. The last one is going to be a status. Nope. Let's look at the first. that to update on Twitter. Okay. Copy this to that. Okay. Control again. Status. Constant charger status. Okay. This main file. Main file is test the stuff that we have from previously. Wow. Okay. All right, so the step is like this. We need to, this value that we have need to be encoded into a single string, which will be used later on. The process to build the string is very specific, as we already have percent encoded algorithm, so okay, it's fine. Every key, whatever we assign. So basically, we need to percent encode every key and value here. And the second step is sort the list of parameters alphabetically. So this step we're going to do manually for this first, yeah. And the third one is for each key value pair, append the encode key to the output string. Each key value pair, append encode key to the output string. Append encode value to the output string. Okay. If there are more key value pairs remaining, append ampersand character to the output string. Okay. Right. We're gonna do it by hand. Yeah, we can improve this later to be more flexible and make like the function that apply for all of the API being like a worker function, something like that. But for now, yeah, let's make it quick because we have the goal in mind already. No need to go over like that. Status first. We need to percent encode. Percent encode. Okay. So we may have to define the buffer for this. See resource string. Let's make it 2 megabyte maybe. Too much maybe. 1 megabyte can be as well. Okay, I'm gonna define this as buffer resource size. Let's make it 2 megabyte. Buffer resource size. Go back. Okay. resource string 0 +1 for now terminate character here. Size of resource string. Our resource string is going to go through a few of the steps. Whenever we finish all the 7 steps here, is not just finished yet. We have to go through two big steps at least, I think. Yeah. So okay, now we have resource string. What we're gonna do next is to person encode the status key and value first. You see here. Okay, I'm gonna encode it. Can I use this? Let's see the function of this. Okay. Size. I'm checking the size and parameter of the SNSprintf. I think it defines the maximum of size that it's going to operate. Less than is okay too, so I'm trying to confirm this. Where is it? Try to record string. The function will write at most. Okay, the SNPrintf and blah 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 here functions will write at most size -1 of the character printed into the output string. The size character get the remaining. Oh yeah, so the last one is going to be automatically now terminate. Okay. Yeah. Okay. Right. We can determine the size of the input status at this stage. So let's do it. Get the we can predict the worst case of the size that input string when get into %encode, how long it is going to be. So we can predict that and define character string buffer beforehand. Determine the worst case of after %encode string for input status string. Okay, so it's going to be status string length. Status string length is going to be string length status multiplied by 3, because if for the worst case every character need to be %encoded, so yeah, multiplied by 3. Yes, just recall a little bit the %encode here. Recall a little bit %encode. Yeah, %encode here. Yeah. Yeah. So it's like a ladies space plus gentleman is going to encode as like this. So as I said, it's multiplied by 3 because if we predict the worst case that every character needs to be percent encoded. So this is it. Yeah. Close this page up. And okay, we got the percent size, and we use this to as a size here. Input character is going to be percent encoded status. Yeah, we have this function already. Percent. Yeah. Actually, we can do in just one single line here. Because we already use SN printf, we can just define all the thing on the start here, and the buffer size is going to be the size of the maximum for all. So we don't need this. Status. The result is going to be something like this. VRS. Okay. So let's sort it. Let's sort it. Sort. Okay, gonna sort this by hand. The first one going to be OAuth consumer key. The second one, this is going to be sort lexigraphically. OAuth ABCD ABCD FGS ILMN or an ST signature method or timestamp or token or version. Yeah, so this is sort already, and the last one is going to be the start of the Twitter update string. So here we are. Okay. We're gonna do OAuth consumer key. This is going to be a very long string here. S and use and to append between the pair of key and value here. Next one, we're done with this. Nose and equal %s, and yeah, I think I kind of like the SNSprintf function here, quite handy. OAuth signature method. Right, we can copy here. Our signature method s and right OAuth times that the same and OAuth token the same. Done. OAuth version the same. Everything is going to be string. The same. And the last one is status. Yep. Right. And now it's time for. So yeah, buffer resource size I hope is 2 MB is large enough. We will see. Yeah, should be large enough. So status we cannot be more than 200 and something for the Twitter new limitation number. Multiplied by 3 and this and that. Maybe 4 bytes is more convenient. Anyway, yeah, we can define this much more. Reduce it later. Yeah. I remember the tip. No, I remember the technique that game developer out there, like before they well down to develop the games, they just define a large enough buffer, not just large enough, is exceed what they wanted, what they might need. So maybe they allocate 2 bytes more, 10 bytes more, and then whenever in the later step of the development, already finished, already done, it's polished now, and they found out that, oh, the games, no, we need more memories, the game need more space, so they just find that code and then reduce the allocation. Oh yeah, we fixed the problem. OAuth consumer key. Okay. Yep. So consumer key we accept from the function already, and we need to %encode it as well. I'm gonna define something here for the convenient for us to call the function. PNC 10. Yeah, this is %encode in short term. This is called %encode. Yeah, right, and then we can do this OAuth consumer key. Yeah, because I have a little bit long of the function name here, because I use netcase. OAuth consumer, OAuth and OAuth signature method. Yeah, signature method, and then OAuth timestamp. OAuth timestamp. Yeah, we need to collect the OAuth timestamp into convert it into string first to which function we use? A to I maybe. I to A, yeah. La la la. Now. Okay. I to A. But it's just non-standard. It's just non-standard function, so I can avoid using this. Yeah, it's a little bit dangerous as well that we didn't know. Oh. Let me see. Hey, thank you for coming, Besley. Since I saw you yesterday as well, yesterday's stream. Thank you for coming back. Yeah, and other people as well. Yeah, I might not be able to pronounce your name, but anyway. Ni hao, ni hao, ni hao. Yeah, ni hao. Okay. Okay, it seems like ATO I is a standard function, but integer to string is not. Yeah. I'm gonna try to avoid using non-standard function here. Yeah. We can do that with the SNPF in this case to convert back from timestamp, in which case is I think it's long data type, and then we can convert to the string character. Yeah, I mean string. Yeah. Okay. The question here is that why I to A is not? Why? No, I to A has ever been standardized, so to add it to the standard, you would need a compelling reason and a good interface to add it. Most I to A interface that I have seen either use a static buffer, which has really entrancy and lifetime issue, allocate dynamic buffer that the caller needs to free, or requires to apply. Okay, so we're gonna avoid using this, even though it seems to be. Actually, it's very similar to SNPF, but it can supply whether the base, which base you want to use. Okay, I'm gonna use SNPF here. Yeah. Okay. So I wanna see how long of the timestamp string that output here. Okay, code. So 10 character, I'm gonna allocate 10 character here. Timestamp string 10, and remember, +1 memset every time memset, because garbage value might get into our value, we don't know it, so this is to make sure. Size of 10 timestamp. Oh, come on. 10 timestamp. 10 timestamp string. Oops. Okay. Okay, space for timestamp. Preparing for conversion from law. Yeah, up to string. Right. And now convert it. Convert from timestamp to string. SNPF here. temp times the maximum size of this is going to be the size of, yeah, size of always return all of the total byte that we allocate for that variable, but string length is going to be, yeah, it's gonna count if it find non-terminate character, is going to stop at that point. So in this case, it's going to return 0 if we do like this. So don't do that. So we're gonna use size of here. Times that. And yeah, string from yeah. Okay, moving on. Signature method we already defined it. Okay, we're gonna add 10 times that. What else we have here? OAuth token. OAuth token. What else we have here? OAuth version. And the last one is status. And that's it we have. So we're gonna just return this thing, resource string, and let's see what's gonna happen. Oh, not, yeah, we're gonna check a little bit. So I don't need this anymore. Right, I can write a file and I can delete it later. Anyway. Okay, so the function in question test is this. Okay. Means I need to take a look at the function file. Function signature here. No. Utility hash. Okay. The first one is going to be HTTP method. Right. We already have enum here. HTTP method is going to be post. Right. The next one going to be request URL. Request URL here. Oh, not yet. Enter this one. It's not used this yet. The third one is status. Yeah, we're going to use the same. Where is person encode here? Going to use the same status text, so we can check it back later. For example, use ladies and
let's go back.
For our consumer key. For OAuth consumer key and OAuth token here is the, I cannot show on stream because it's something that is very privacy, you should keep it to the yourself application and not let anyone else see it. In this case, I'm going to read from your system environment variable. So I'm gonna define the environment variable for OAuth consumer key and OAuth token here off the screen. You don't see it on the stream. But basically, you're gonna do something like this. You're gonna modify the file here. Bash. I'm on Mac OS, so in your case, you're going to be something like this. And then inside, you're gonna do something like my OAuth token, and then blah 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 here. Yeah, and we're gonna read that variable in C source code here. Let me define it first. This is off screen, you don't see it. Okay, I have it already. So I need to read it first. If I print it, you're gonna see it anyway. So I'm gonna define something. Just testing first. Then, yeah, because I think you're gonna see it at the end anyway. Okay, key and noise here. Oh no. Generate. Vent. Okay. So how long of the noise that we need to generate here? Let's check the length. 42 character. I'm going to delete this too. And generate noise. 42 character. That's that. String. Noise. 0. 42. Okay. Generate noise now. With TTU2 generate noise. And destination string is this. Length is 42. I can define noise as well. So be more on the clean code side. Clean code, yeah. Sorry about it. Yeah. Right. La, 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 la. So we got noise that, and we just use it. Okay, let's go down and see what else. Nice. Signature method. Signature method is going to be exactly the same every single time. Right. What else? Timestamp. Okay, we're gonna get timestamp here. Get timestamp. Yeah, use the function right away. You can see at the bottom here, at the bottom panel, you're gonna see TTU2 get current timestamp. TTU2 get current timestamp. Yeah. Actually, the implementation of that is this timestamp. Where is it? Oh. I didn't implement it yet. Anyway. Yeah. 42 time to TTU2 get current timestamp. Yeah. So just return time. That's it. Okay, what else? For our token, this is going to be this is for test first. Consumer key. I just want to see the result string whether it's correct or not. And the last one is going to be version 1.0. And right. Okay, I think I made the same problem last time. I should not do like this because it should be, yeah. So what I can do is to move this up. Hey, hello, Lovebox Game. Welcome back. How are you, man? Resource string. And set. Yeah, let's define the name much more clear on this. DST signature string. DST result signature string. Okay. Oh, wrong. DST. Oh, come on. DST result signature string 46. Okay, the same. Yeah, and just telling you that actually the stream I'm gonna go live like this is mainly for the game project. It's not application or something utility like this. But for this few days, for this time, I just wanna warming up a little bit and implement this Twitter CLI that I can tweet via the command line. Yeah. But the actual thing is that what I'm gonna show later on after this project finish is that gonna develop this game. If you didn't see it yet, for new people that didn't see the project just yet, this is it. This is a game that I'm going to develop and live like this every single day. Yeah, mostly every single day. So it's already released back in 2015 October. So around three years ago, right? On mobile iOS, but for now, I'm gonna do this for PC and other consoles. So this is it. This is the game. You can search and type zombie hero here, and you can try to look. I can show you a little bit of it. Yeah. So basically, you're going to be a main character fight to the zombie to the stage, yeah, and you're gonna see the character that you already known in cartoon world, yeah, something like that. So it's going to be for PC first, maybe Steam, yeah, definitely Steam, and but there's also another store that most indie developers here pay attention to it, and they give much of the percentage to the developer. Is Epic Store is get 88%, I think. Yeah, I remember correctly. Much more than not 88, yeah, 88%. Yeah. But for Steam, they take the cut for 30%. Compared to Epic Store, it's just 12%, and it's quite seems to be in the healthy state right now, and yeah, they pay attention to this. So let's see what happens later. This is just the early state that I try to do. Okay, let's get back to this. Resolve signature string. Okay. This is not resource string anymore. It's going to be dst. Yeah. dst resource string. dst resolve. Yeah. dst resolve. So doing it like this, I already repeat in the previous stream that if you define it in a source file like this, so when you return it, user has no need to free the string. Like if you, in case you allocate the buffer for the string inside the function dynamically, so it's put the burden for the user to free that buffer again. So I don't want to do that. Let's make it simple and then just return what we already have. So this function is not going to be thread safe. Yeah, not thread safety, because we need synchronization as that variable already defined. Yeah, if multiple thread access it, we need to somewhat protect it. So I'm gonna note it here that no, this function is not thread safe. Anyway, we not going to be multi-threading for this app. Just simple one. Okay. It's going to return signature string. I'm going to print it here. Signature string. Let's see. Noise length. Oh. 8. Okay, let's compile it. Whoa, a lot of error here. Let's fix this one by one. Add utility 5 here, 86. 86. What happened here? Temp time step, right? Okay, let's do it again. 88. What happened? Temp time step. Okay, 88. Oh. Okay, is this? Oh, yeah. My mistake. What else? 10 times that. 10 times 10 times that. 90. Alright. Maybe colon. I use Golang for backend, but for not for this project. Yeah, maybe if you're familiar with Golang, yeah, it's okay to use that. Maybe faster for you guys. Yeah. 2K, yeah, but I'm not using that. I'm using C because I'm gonna use C for the main game project. So I'm not using Golang for now. But as I use Golang for the backend, yeah, I love it too. Yeah, you similar sense, but have some kind of like things on a little bit more flexible to do. Okay, I lost train of thought now. Where is it? Resolve. Buffer resource size. Buffer resource size. Okay. Okay, we got it now. Seems to be correct. Let me check the gentleman. Make signature string. Okay, ladies. I think you see it, right? $20 to be $20. Okay, it's correct. What knows? Okay, nose is not correct. Oh, something wrong. Something wrong.
Let's go back.
Oh, okay. I got it now. because percent encoded use just one, because percent encoded use one single string variable at the top. Yeah, so need to a little bit effort here. Yeah. Okay, let me know choice. I'm gonna allocate it dynamically then. Let me know choice now. And then it's going to be tracer.